point and add delta x. And you'll see that there are five values. All right, so
Wait,
I'm
where
going
are
to
these
cover
five
this.
values from?
Say that again.
Are these five values just because we need five? Our n is five, or what?
Yeah, I'm gonna get all that here. Make a little more
Okay.
space. Okay. So for a left sum, because you're going to do left, right, so on. For a left sum, you use these. For a right sum, you use the right ones. Big
Okay.
surprise there. The mids where it gets a little bit weird. You actually have to recompute them, the midpoints, which is kind of annoying, but you have to do it. It's actually the longest calculation for the mid.
Mhm.
And the trapezoid uses all of them, but you end up multiplying this one by 1, 2, 2, 2, and 1. Hopefully you saw that in class.
Yeah.
Are you using Simpson's rule as well? Or is that not yet?
Not yet.
Okay. So these are the numbers that you're going to put into the function
Okay.
based on whether you're finding the left, right, the mid, or the
Okay.
trapezoid. Okay, so for the left one here, let me for the left one here, and it's delta x times f of -2 plus f of -1 plus f of 0 plus f of 1.
Okay.
Your delta x is 1, and then f of -2 means to put -2 in for x, like that. That's f of -2. Then you're going
Okay.
to do -1, then 0,
Wait, where's the
then
plus
1.
six coming from?
It's in the integral. I just
Oh,
made that one
okay.
up. It goes in the
Okay.
whole thing there.
Okay.
Okay, so you do all this and you get a number. -2, -1. So I believe you get 18.
Okay.
Okay.
That makes a lot more sense because in class I was like, how am I getting a number at the end?
Yeah. So the right one, it's delta x f of -1, f of 0, f of 1, and f of 2.
Okay.
And you're reusing a lot of these. You don't have to recompute them. Like if you're careful about how you do it, you can just grab the numbers. Um,
Yeah.
but you're putting it back into that same function. So it's still -1 squared plus 6 plus or negative -2 squared plus 6. Delta x is still 1. And you notice I've sort of like left this space. It's to represent like that there is some overlap between the left and the right.
Yeah.
It ends up being a 18 again due to symmetry. That it's not necessarily always the same.
Okay.
Okay, now the
And
midpoint question.
whenever you were like picked your points, like two, -2, -1, did you just like evenly separate them, or like is there a certain way to find them?
Yeah, you start at A, you have to go to B, and you add delta x.
Oh, you add delta x each time.
Yep,
Okay. A
and
minus
so
B
on.
minus. Okay,
Very good
that actually.
question. I like to write them out. That way I know which ones I'm using.
Okay.
That's my preference. Okay, so mid's the one where you can't really reuse anything. It's awful because they're already kind of annoyingly long problems, but it's f of -1.5 plus f of -0.5 plus f of 0.5 plus f of 1.5,
Okay.
like that, times 1.
Okay. And so,
And question?
like integrate, like to do this, and there's like the integrate sign, and then like the regular integrate where I find the antiderivative. How do I know the difference of that?
They're all the same. So what we're doing here is a numerical approximation.
Okay.
Like this is like what you're asking is minus x squared plus 6 dx from minus 2 to 2. Um, all these numbers are giving you approximations of this. You can also, we know how to find the exact, but in real life, you don't know how to find the exact very often.
Yeah.
So you have to use all these numerical techniques.
Okay.
So trapezoid rule. Um, I believe it's delta x over 2 now.
Yeah.
Okay. And then it's f of the left endpoint plus 2 times the next endpoint, all of them except the right endpoint. And so you just compute
Wait,
whatever
don't
that
we have to
is.
add 1/2 of the last endpoint?
It's 1. It's 1 and 1.
Oh,
I would
okay.
keep the 1/2 on the outside.
Okay. And then just plug them in, right?
Yeah.
Okay. That actually makes a lot of sense. And like, what's the purpose of doing this? Like, finding the area underneath the curve.
So again, in real life, you integrate a lot and you integrate functions that aren't nice. Like I'll just give you one that doesn't work. You can never, this is not integrate, you can't integrate this ever.
Okay.
That's not, I mean, it's not completely true, but like it's way out in the math world. So you're really stuck. So these techniques allow you to find the area under the curve. Like this thing has a shape like this. We can find the area under the curve if we want using these techniques. And
Yeah.
they get better and better and better as you learn more of them. This is a very small part of this course. Like you will not see this again.
Okay.
I don't even know why it's in this course, but in your course, but that's what it is.
They said it's on the AP test.
It very well
Unless
could be. Oh yeah, yeah, it is. They always do it's a free response question and it's always a table and it's weird. It's not actually like these. The delta X is never uniform. You have to actually like use a modified delta X for each one. So when you get to the AP, I'll be happy to show you that.
Okay.
Okay, so we don't have a ton of time. We can maybe do like one more problem, setting it up, not necessarily compute it, and then maybe talk a little bit about whether it's like it's upper or like whether whether the answer is like too big or too small, or we can jump right into that now. What would you like to do?
Yeah, let's do that.
The second thing I said?
Yeah.
Okay. So let's say I give you a curve that looks like this, and we want to calculate a left sum.
Okay.
So I'm going to draw the rectangles. It's really important to draw the rectangles. What do you notice about the area of the rectangles compared to the area under the curve?
Um, I don't know.
Okay, so here's the area under the curve. This is in red, all of that.
Okay.
The the rectangles are bigger. There's more area.
Hmm.
So this is considered an oversum.
Okay.
But if we take the same curve and we do a right sum, so we start at the right, what do you notice the differences about the right sum? Is it an
The
over or
area
under? It's
under.
an under. Okay, so the answer as to whether it's an over or an under depends on whether the function is increasing, decreasing, concave up, concave down. There's no like hard and fast rules that are worth memorizing. There are rules, but they're not worth memorizing. It's best to draw like sort of these rectangles and then decide.
Okay.
So for example, here, let's say give you something like that, and we do a left sum.
It would be under.
it would be under, right?
Yeah.
And a right sum would be,
Over.
that's why you got to make sure you draw it from the right,
Okay.
which could be, awkward if you haven't done this in a while. So this is the right, this is the left. Okay, now where it gets more difficult is now let's talk about midpoint. So I haven't drawn this real well, but you basically go up and hit it and then go left and go right, left and right. And so you're sort of deciding like, well, is the area that's over it like we've got some areas above it, so I'll do the like that's
Hmm.
above it, above it, but then we've got some areas that are below it. Like how do they cancel out? So it depends on the problem. You're basically looking at like which is bigger, the overs or the unders.
Okay, and we want the one with the least space, right?
Typically, yeah, like so really challenging problems to figure out which is the smallest error. Now, so this is mid. So it gets even more complicated with trapezoid. Trapezoid, you're literally drawing these trapezoids. So these are
Yeah.
all under. But if I change the curve a little bit to this, now all the trapezoids are over.
Hmm.
So it really depends on, like I said, whether the function is increasing, decreasing, concave up, concave down. It's best to graph it if you can and know like an approximate of the graph.
Okay.
But to answer the question, so left and right are the worst, typically.
Yeah.
Trapezoid's better than mid, but not always. There's other, I mean, there's whole courses in this on this. So if you're really like, if you're really interested in this, you can see this in college. Take some, really advanced math classes.
Yeah.
Um, right. But my guess is you'll just be asked whether it's an over or an underestimate, something like that.
Okay.
Okay,
Okay.
so we should take a look at a problem like one of the problems in like 3, 4, 5, 6, 7, 8, 9, or 10. Any of those stand out to you, or even 11.
Um, I guess let's do 7.
Okay, so here's what they have to tell you. They have to tell you the endpoints, which they have done. They have to tell you A and B. They also have to tell you the number of um, they have to tell you the number of intervals. So if you notice, it says like U4, L4, M4, E4.
Yeah.
That means N is 4.
Okay. N equals 4.
So
So
the
it's
first thing is to calculate delta X. Question?
I'm saying delta x, right? It's b
Yep.
minus a over n.
Yep.
Okay. 1.2.
And then I like
So
to start with the leftmost endpoint, add delta X.
okay.
You do not have to do this. This is just a recommendation.
Okay. And then
So
where do
now
we go?
let's do what do you want to do? Left, we can do them all. You want to do them all or do you want to do just certain ones?
Say specifically. Oh wait, I find this one by applying it. It says trapezoid rule.
Okay. So trapezoid rule would be delta F two times, I'm sorry, not two times, F of 0.4 plus F of 0.6 plus, and there's two of those, plus 2F of 0.8 plus 2F of 1 plus F of 1.2.
Wait, why are we multiplying it by 2?
What did you said trapezoid?
Yeah. Oh,
That's the
over 2.
formula for trapezoid. Sorry, there's a Oh, I see now. Okay, so I guess some instructors do one half on the first and the last and the others by one. That's not really standard, but maybe
Yeah.
that's the way they saw it. So we got 0.2 divided by 2, tangent 0.4. Make sure your mode is in radians,
Okay.
plus 2 tangent 0.6 plus 2 tangent 0.8 plus 2 tangent of 1 plus 1 tangent 1.2. These are all calculator problems, so
Yeah.
you're not going to get a.
Okay.
So
So
tangent, the graph of tangent, if you haven't seen it in a while, it looks like this. That's like, well, is this an over or an underestimate? Looks like it's an overestimate, a slight overestimate.
okay. So when you draw it, then you find out if it's over or under.
Typically, if you know what the graph is like, of course.
Okay.
The other thing you can do is did you guys get do a math 9 on your calculator, FN int?
No, we have not. He said he was gonna give us something that like helps us.
So this is already built into the TI 8384, but you can integrate this and it'll give you a number and you just
Um,
compare your result to that number as well. That's sort of the cheat shortcut.
I did not know
Um,
this existed.
it only works for certain integrals. It's an approximation, doesn't work for everything.
Okay.
All right, let's take a look at the midpoint for this one. How is the midpoint different from what we've done? Well, you need the midpoints.
Yeah.
So you basically don't get to reuse anything you've done. It's just delta x, f of 0.5 plus f of 0.7 plus f of 0.9 plus f of 1.1. Tangent 0.5 plus tangent 0.7, tangent 0.9 plus tangent 1.1.
Okay.
And
And
really hard. Go ahead, question.
the midpoint and like they're all gonna give you different numbers, right? But like there should be relatively close.
Yeah, depending on, yes. I mean, the answer is yes, but it's like I couldn't say how close. Um,
Yeah.
what other questions do you have?
Um, I actually don't really think any because I just needed clearing up on like how you find a number at the end. I didn't realize you had to plug in like the points, I
Yep,
guess.
back in there.
Okay.
Occasionally you'll get a problem like this. I'll just show you this is your last thing. They'll give you something like T and V of T, and they'll say like 0, 1, 2, and 3. And I'll say, I don't know, 60, 64, 62, and 70. And they could ask you to do all the same things we've been doing here. Um, Basically, they're asking you to integrate V of T from like 0 to 3, but it's a table
Yeah.
now. Did you guys see any problems like that in class?
No, we haven't.
Okay. Do you want me to proceed or just,
Yeah, because I feel like this is something that he would put on the
okay.
test.
So the left sum, it's still delta x, but this times it's V of 0 plus V of 1 plus V of 2.
Okay.
And then the right sum is V of 1 plus V of 2 plus V of 3.
And when we're
If,
plugging in, like v of
well,
0,
yeah, I'm gonna give you the numbers now. So you have to compute some of this, but delta x is like 1 minus 0 or 2 minus 1 or 3 minus 2, which is all 1.
mm-hmm.
And then it's 60 plus 64 plus 62. And the right is 64 plus 62 plus 70.
Oh, okay.
And you could be asked to do like a trapezoid, but not a mid because you don't have the mid. So your
Yeah.
trapezoid though would be the delta x over 2 v of 0 plus 2 times v of 1 plus 2 times v of 2 plus v of 3.
Okay.
So I'm running out of room here, but it'd be like 1/2 60 plus 64 plus 62 plus 70. But you have 2 times that one and 2 times that one to consider.
Okay. That makes sense.
Okay, that will probably do it for us for tonight. Hope that
Yeah.
helped. I gotta stop the
I did.
recording.
Yeah.